Well, I was a rookie pilot on board, so my eyes were real big staring at those main engine gauges about this point. Of course, the left engine said 40%, so we were convinced that we're not going anywhere. We're pad abort today. So we were getting ready for our pad abort, and all of a sudden, the main engine's SRB's light. Well, it's exciting enough to ride the rocket, but it's even more exciting right about now because we also have the fact that the computer's not talking to the engine, at least it says so. But Andy calls the roll program, tells them what we got, and the ground comes back and says, you got 3 good engines, so we're off to space. It's a heck of a ride, especially for a rookie. I mean, it's just a tremendous amount of power. It's smooth. It shakes on the SRBs, but once you come off the SRBs, it's like an electric jet going as fast as you can imagine. Probably the most awesome sight during ascent was leaving Earth's atmosphere behind and going into the darkness of space. Quite a ride.
As soon as we get into orbit, we have to configure the shuttle for orbit operations. This is a nice picture of opening the payload bay doors. You can see the shadow of the starboard side of the shuttle on the door and the Earth in the background. There's some spectacular visual effects soon after you get into orbit. We're in the post-insertion period, we're using primary thrusters, and a lot of the ice which is formed in the main engines, because we're burning hydrogen and oxygen is coming out as crystals. You could see the RCS fire in there. It's quite exciting.
And next is the view of the flight deck. 1 hour into the post-insertion, you see somebody still wearing the underwear. But we were already hungry, and you can see we had a big appetite at this point. Everybody felt great. And this is a view of the first sunrise on the cargo bay. On the foreground, you can see the Tether satellite. On the background, there was a USMP.
Well, a lot of stuff to do, lots of equipment to set up, computers, cameras, video stuff, audio, lots of wires, and all of it in preparation for the big moment, which was the deployment of the Tether. And here I'm setting up one of our major computers, which not only helped us on the science, but also to keep in touch with the ground and also our families down in our homes.
Next, there will be some shots about the boom deploy. We are very much into pre-TSS deploy activities. The first thing, of course, is to deploy the boom. The purpose of the boom was to basically take the satellite away from the orbiter structure. This is an accelerated view, which normally would take about 12 minutes. The boom is an incredible piece of engineering. You can see it in these shots. You can see the actual tether in the middle and all the electrical wires. The satellite was lodged on top of the boom, and just underneath the satellite you could see what we call it a vernier motor, which was basically an auxiliary motor which helped extract the wire. We had an attitude, this kind of attitude, while flying basically backwards with the nose pitched down about 40 degrees, and that was due to the particular dynamics of the deploy profile.
And this is the initial flyaway of the satellite. It's pushed by 2 sets of 2 Newton thrusters, so very small thrusters pushing that half metric ton satellite upwards, cold gas thrusters. Everything happens very slowly at the beginning. This is accelerated 3 times, but the velocity initially was about 1 centimeter per second. Everything went very well at this time of the deployment. Everything was controlled, and you see here a little later the tether is taut, which is always something we desire to see. Because it's much more controllable this way. Slight oscillations, but we were predicting those, and that was not a problem. So a very controlled initial phase of the deployment of the tethered satellite.
We're going to see a few sequences here of the phases of deployment. This is the early phase, and as you see, it looked pretty straight, low tension, and you can see a little bit of the wiggles of the tether in the bottom. But everything completely nominal. The tether speeds up and it gets to a high speed of about 2.2 meters per second maximum. And as it does that, it begins to, of course, develop a little bit of a bow. And you can see the bow as it begins to grow, as the tether gets longer and longer. Of course, as the tether gets longer and longer, also begins to generate more and more power. We were generating quite a high voltage and, of course, able to collect lots of current. And all in all, on the order of about a couple of kilowatts of power were being generated. You can see also the progression of the bow at this, in this long shot picture near the satellite itself.
And at 19.7 kilometers, we were looking at the shape of that bow when I started to notice, you look at the left-hand side, some waves going up and down the tether. Clearly the tether had gone slack, either because of a jam or a tether break. Looking back, we quickly saw that, in fact, the tether had broken. This was a very it's a big shock. It's kind of an empty feeling in the pit of your stomach when you look and you realize that there is the tether moving away from us at about 80 feet per second, and you just wanted to reach out and grab it and pull it back. But, of course, there was nothing we could do. There you can see the end of the tether coming up in the lower part of the field of view. And so at this point, of course, we have some procedures which we're trained in.
Basically here, at this point in time, there's 4 of us that were awake, the 4 veterans, the 3 rookies were sleeping. And of course, the very first concern we have is to make sure that none of this ball of tether starts coming back towards the orbiter. We were concerned pre-flight, and we did a pretty good share of training pre-flight, that if we had a ball of tether coming back at us, we'd do the proper evasive maneuvering to make sure we didn't have a big problem. But it all stayed with the satellite. The tether actually broke inside the boom, so there was nothing required on the orbiter side of the house other than to monitor the satellite.
And this is all that's left, or that was left, just a stub of tether, and in close view with a very powerful lens we had, we could see that it was charred and it was burnt, and this was further confirmed later with the hardware of the Cape. There was nothing much to do except to retract the boom and really get ready for the remainder of the flight, which was concentrating on microgravity science, and it was a whole mission to do. These spectacular views actually were taken from the ground by Paul Maley from MOD. He was in Australia, and he was able to capture a glimpse of the tether, and you even see a meteorite go by just for a glimpse there. So we are very appreciative to Paul for being able to do that.
After the tether was over, we still used the top camera that was supposed to be used during the tether activity while we had current flow in the tether to observe glowing. And we used to point to the Earth glow and to the lightning that we had during our night pass.
A lot of things behave strange in weightlessness. You've seen pictures probably of astronauts doing strange things with water drops. They behave very counterintuitively. Claude has a little goldfish here, which he's putting in a tank. Of course, and we can blow air bubbles inside the water bubbles. But other things behave strange too, such as flames, combustion, and we did these combustion experiments in orbit.
And here is the place where we did them, this glove box facility, which lived in the mid-deck, and in it we actually burned different kinds of materials. This is one of them. It's just a birthday cake candle, just like what you see on the ground, but the flame looks a lot different. It's more round, and it's more determined and controlled by the amount of oxygen in its proximity. And when the flame extinguishes itself, the smoke just stagnates there inside the cavity, just like what you see. It's not dominated by convection or anything like that. The flow has stopped. If we actually induce a flow, you can see what happens. It's very laminar, very slow, and we use this to test some of the new generation smoke detectors.
This is another one of the combustion experiments called Thrifty. You can see all the little numerical data is giving temperatures of the probes you can see in the flow. It's a cylindrical paper type sample. And there's a very low flow. The little ball on the left side is showing you the flow in centimeters per second. And this sort of looked like a jet engine to me.
And here comes another combustion experiment, Rizzi. We are burning paper samples. In this case, a flash lamp is used to ignite the sample. And the setup was such that there was air flow circulation from the right. And in fact, you see that the flames tend to go to the right. That is quite uncommon with respect to the experiment we do on Earth, while the flame is trying to go the other way. And you see that, in fact, the flame is on the right until all the paper is gone, and then it starts to move on the left.
RADSIG, which stands for Radiative Ignition and Transition to Spread, basically had used paper samples, but two different types of investigations. One was a flaming investigation, which you just saw, and the next one we'll see was basically a smoldering investigation. They were carried out inside this enclosed compartment, which was called a glove box, which provided a safe environment for combustion experiments. Even this sample paper was ignited by radiative, by radiation, and the smoldering was really very interesting. As you can see, it assumed forms that are quite strange. Somebody said, "Don't let the animal out of the cage there." And the scientists are still working on the data we brought back from space to explain all this.
Well, we're doing all that in the mid-deck. Out in the payload bay, we had a lot of microgravity experiments. This is a picture of some of those. And one thing to be careful with is like if you were doing exercise. So here I'm on the ergometer, and it's not during a microgravity period, obviously, because this actually could shake the whole orbiter, and we had to be careful of that.
Even a simple activity like moving into the cabin has to be done carefully when you are in a microgravity environment. We had the accelerometer on board that allow us to see real time our contribution to the micro-G environment, and that was very useful to keep it very low.
Of course, there are lots of other things you can do while being quiescent, for, of course, eating and taking care of the cabin. And of course, we had to update all our documents. The updates came up on a sort of fax machine that we had on board. And with Scott and Umberto, as first-time flyers, we tried to spend as much time as possible, free time, of course, looking out of the window. Here we are flying over Chad, and unfortunately the movie doesn't really do justice to the real colors that we will be able to see from space. We are around the Tibesti region, and the colors are really, really bright and vivid, and this is something that really catches your imagination. After this, we'll move on to the Nile Valley, which is, of course, one of the places that is very easy to detect from space, because you can really see the difference between the green of the area around the Nile and, of course, the desert around it. We tried to take shots of the pyramids several times. Unfortunately, we always overflew the pyramids around noon, and so we couldn't use the shadow to detect them. And strange enough, there was always a thin cloud layer hanging over the pyramids. Maybe next time.
Then we flew out into Asia, and this is a zoom shot of the Mount Everest region. You can see Mount Everest right in the middle, Makalu below it, and the Aran Valley. And then we zoom back, and you see really the whole Himalayan massif with the Indian subcontinent on the left crashing into the Tibetan plateau on the right. And if you take a strong zoom lens, you aim it at these mountains. This is the easternmost part of the Himalayas. That's the top of the world. And we're overflying China now, actually out over the Pacific Ocean, and you can actually see the Himalayas set behind the horizon. It's a pretty spectacular view. It really puts you in orbit.
One of the very important things to us on board, obviously, is our personal mail from home. This is just a picture of coloring that my daughter did.
This is what a water dump looks like in space. The water immediately crystallizes to ice crystals, and as we are crossing the Terminator, it's really a beautiful sight. We were doing this periodically to maintain the water in the tanks on board the orbiter within predetermined limit. And this is Jeff and I looking out the window at the sunrise. And during the night, we had a lot of moonlight during the nights, and you see these crystals of ice that are following us and are twinkling in the over the moonlit landscape. Really beautiful view during the night.
Well, it's been one heck of a journey. We've done a lot of experiments. We've seen a lot of great sights. And now you can see the folks on your flight deck. You're probably with his glasses again, ready to go. And we're all ready on the flight deck in our suits, ready to come on home.
And the same situation seen from the mid-deck. We were very busy getting ready for re-entry, and you see a lot of stuff floating around, included our parachutes that are still up in the air, you see. And we have to do this twice because of the extra day.
This is the last pass over the Himalaya, and you see the full moon, or nearly full moon setting. It's always very impressive to see how fast the moon and the sun rise and set. And this is the view of the moon sets with a telephoto lens, powerful telephoto lens, about 400 millimeters. And due to the differential refraction in the atmosphere, you have the whole moon that is completely crushed as it penetrates the lower layers of the atmosphere. Very beautiful sight.
And now we're re-entering. If you look closely, you can start seeing kind of a red glow out the side window there. As exciting as launch was, re-entry was just as fascinating, especially as you come into in the atmosphere going Mach 25. The sky turns a pink and then a deeper and deeper red and orange. And then you break out, and then you can see below going a mere Mach 15 over Houston. We went zipping by, and Andy was nice enough to leave us in a right bank so I could look out my window.
Those puffs of smoke are the RCS jets that shut off just prior to Mach 1 as we're coming into the Kennedy Space Center. We did have a wave-off day, but finally it was a pretty day. There's the east coast of Florida going by Scott's right window there. And we're in a right-hand turn here to land on KSC runway 33, heading towards the north. Atmospheric conditions were great that day for the folks on the ground to see us, as well as when they heard us when we did our double sonic boom. So we made some nice contrails coming around. The vertical assembly building's out on Scott's right window again. This is over his shoulder. As we come on back in, it's the standard world's worst glider at this point, 300-knot dive, 20 degrees down to the ground probably. And Scott finally gets the gear out down there at about 350 feet. But that was just like we had planned. And at that point, we continuously decelerate as we're coming across the runway. The shuttle training airplane, which had been giving us a lot of our landing data previously, is coming by our left-hand side there. Tried to make the black marks there, but landed just a little bit short. Some wind shears that day and headwind helped me do that. We put the drag chute out to continue the deceleration process. It's a real hard thing to do, to lift your legs up to get on those brake pedals, and you got to do it because you don't want to look bad on CNN. So I get the legs up there, get on the brakes, but the deceleration from the drag chute provides us quite a bit of deceleration, so it's not that hard of an effort. We dropped the drag chute off at about 60 knots or so, just prior to coming to wheel stop, and we were just real happy to be home.